Hi, and welcome to Becoming More Effective with HL7 Feeds. My name is Stefan Wittmann, and I'm a product manager at InterSystems. I'm looking after interoperability in general, and I'm based in Germany, so if I speak funny, let me know. In the next 20 minutes, we're going to take a look at, a very complicated topic actually. We're going to take a look at how we can lower the cost to upgrade productions or to move from one version of the server to a newer release and verify that the behavior of the given production hasn't changed. Well, except at those places where we want the behavior to be changed, right? But we want to make sure that there are no unwanted side effects in addition to the changes that we're introducing. So that's what we're going to take a look at, verifying that the production hasn't changed. And in combination of that, we're going to take a quick look at how you can compare two HL7 messages against each other and see where the differences are. And the second bigger talking point is going to be how we can build and generate DTLs based on sample HL7 messages. So that's a new concept. Both of these topics are not released yet, so we're talking about features that are not in product yet, they're still in development. But I want to give you a sneak peek and give you an idea of where the product is going. Without further ado, let's take a look at upgrades and why they consume a lot of time. There are plenty of potential challenges when you upgrade a production or a server. I'm keeping the slide generic on purpose because it can mean you're upgrading your production, you're introducing new logic. It can also mean you're upgrading your server or your environment, and you want to make sure that the behavior hasn't changed, it's still the same. And the problem really is that you want to identify any kind of changes in behavior overall, right? But it starts with very simple problems that not all your data feeds are using the same protocols, right? Some of them might be file-based, but other data feeds are coming in through TCP or through mail, which are much harder to isolate and temper in a test environment and make sure that they actually still behave similar to your production environment. That's not so straightforward. You might not have a good test environment for all of your data feeds, maybe for some, but not for all of them, for various reasons. And very often the problem is that you might not have good test data to build up a good test environment anyway. And there are plenty of more things that can make this complex. This is just to have a common baseline around what some of the problems are. So let's take a look at what we've been thinking about when we're talking about production verification. So let's take a look at a given Iris instance or a Health Connect instance, if you will. Usually within the production we have three major components that we care about. We have on the left side the business services that take messages from a source and consume it, and then send it as a request to routes. And these routes, they can be single-tiered, they can be multi-tiered. They take care of the routing of those messages and also include the transformation to the target format. And these target messages then are being sent to business operations on the right side, which send the messages to the upstream services. So part of the problem obviously is that these messages can come in through the file system, which is, well, that's easy to handle with, and it's also easy to simulate because you can just copy files and send them to a directory or to a test directory and pick it up. That's really easy. But they can also come from TCP streams or emails and so on, and that makes testing much more complex to set up. The same obviously is true for business operations, for the outgoing side. And that can also be problematic because obviously in your test environment you don't want to send a TCP message or an email to another system, right? So you have to emulate these systems to a certain degree, right? So what we are doing to verify that the production hasn't changed or that an upgrade to a newer version hasn't introduced any unwanted side effects is we're taking all the messages that are being sent from business services to other entities, and we capture them basically in a bag as source messages. We also take all the messages that are being received by business operations and bundle them together as what we call them target messages. And this gives us a baseline, right? It removes the external dependencies of the different adapters and connectivity options, and it takes the inbound messages as soon as they enter the system, and it takes the outbound messages before they actually leave the system, and it establishes a baseline of what we expect. Given a set of inbound messages, what kind of outbound messages we're expecting. That's our baseline, okay? So here's the concept. Assume we're in another namespace now, or in a totally different server when you upgrade it, or in a different environment, like now we're in the test environment. So same starting picture, right? We have the same production happening here, business services, routes, and business operations. But instead of feeding the data in through external sources, now we are feeding in the source messages that we got from our baseline test, right? These messages then are being propagated through the routers and being sent to the BOs, which are disabled, so they're not sending anything to anyone actually. So now we're getting a new set of target messages, and guess what? We still have the baseline of our target messages, what we are about to expect. And now we can take these two pairs of bundles and diff them and tell you exactly what's different, if anything, right? Did we generate messages that we didn't in our baseline run? Did we omit messages, though we should have generated them? Did we generate the same set of messages, but does the content differ? These kinds of questions is something that the tool is going to tell you exactly, and is also going to give you a KPI indicating you how close you are to the baseline. So enough talk about this. Let's take a look at this in action, shall we? So this is a very simple HL7 v2 production with 3 routers that I'm using. I'm in namespace broad. I have the same production set up in the namespace test as well, and I've been using the verification tooling to take a baseline from the prod namespace and do a second run in my test namespace to see if the behavior changed. This is the output of this run, and we can see that the baseline in prod generated 2,000 messages, while the second run in test also generated 2,000 messages. 10 files have a different content, so that something is different there. We have 0 missing files and 0 new files. So overall the KPI, which is a value between 0 and 100, where 100 means everything is identical and 0 means everything is different, and 99 is actually a pretty good value. So if you take a look at the message viewer for the first issue, we can always see the first line of a segment is the output of the baseline run, while the second is the same segment from the second run. And we can see that the name of the first name of this patient got changed. And that's the same for all of these issues that we're seeing here for all 10. And obviously is a very simple case, so that should be simple to fix. In a more complicated scenario, the baseline run generated 9 messages, the second run generated only 8. So there's 1 missing file. Out of these 8 messages, 3 are different in content. So if you take a look at the first one, we can see that there are a couple of fields where the values definitely are different than we would expect them to be. For the second issue, we can see the missing file. The first segment is from the baseline run, but the second run didn't actually have any content for that file, so that's why we're seeing it empty here. The third case seems to be good, but if we scroll down, we can see that the second one actually did generate an OBX segment that was not generated in the baseline run. So overall, this is a tool which allows you to quickly identify if the behavior between two different runs changed or if everything is okay. Okay, the next thing we would like to take a look at is how we can generate details based on HL7 messages. So you might have played around with our migration tooling for Datagate, eGate, or Cloverleaf to migrate transformation logic from these engines to DTL statements in Iris and Health Connect. But what about if you want to move from another engine that we don't support out of the box, or if you want to generate a DTL statement based on HL7 messages where you have samples? You don't want to start from scratch, right? So assume you have a set of HL7 v2 inbound messages and correlated HL7 v2 outbound messages. You can pass those into an Iris instance, and we can generate a stub data transformation for you that will try to basically generate the outbound messages given the set of inbound messages that you provided. We're doing this based on very simple rules. So let's take a look at this. We're not going to run super fancy logic that's going to figure out every kind of scenario, how you could transform codes from one field to another and build compound fields. We're going for simple assign statements, and those actually form up to 80 or 90% of data transformation, depending on what you're transforming here, what your message type actually is. So we're trying to take away the mass work for you, so that you can focus on the elements that are more complex. And the way how we do this is basically we take a look at every segment in each message and try to identify if there's a simple set assignment you can make between a certain field in the source message and the target message. And if that's true for all provided pairs that you've given us in the sample input, then we're going to generate a set statement. We're also going to generate loops for repeating groups, so you don't have to build those by yourself. You're going to generate those. As soon as we generate, or as soon as we find one case that indicates that a simple set assignment can be made, we're still going to generate the statement but disable it. And we will tell you what the ratio is between how often we thought this is a good idea to have this set statement versus how often we found cases where they told us that we shouldn't have this set statement here. So you can make an assessment and enable or disable this statement yourself and make further adjustments because you may need a more complicated logic. That's about the concept here. Let's take a look at this in action, shall we? So the DTL generator is asking you for a source directory and a target directory of where your HL7 messages are actually located. You have to specify the document type for your inbound and outbound side and what the generated DTL name should be like. We're going to use the control ID for matching the inbound and the outbound messages. This is what they look like in my environment. I have a badge of 8 messages for the inbound side and a badge of corresponding messages, 8 messages for the outbound. If I click on execute, what's going to happen is that it's analyzing these two files and it generates a DTL class with set statements for all fields where it has 100% confidence that the target value for that field always comes from the source field where we don't have 100% confidence, we're going to generate that statement and disable it. That's why it's grayed out here. And in the description field, we're going to let you know why we don't have 100% confidence. In this case, for the patient ID, you can see that for 25% of all the occasions, the target value always was equal to the source value, but for 75% of the occasions, the target references were null. And in these cases, we don't really know what are you setting it to null, or is it a copy from the source? So that's why we're not absolutely sure, and we're disabling it for review. You can take a look at the visual comparison, as you've seen earlier in the other demo. And basically, we're comparing the expected output against a run of the input files against our generated DTL. And the output of that run is what we're comparing against here. So we can see, let's say the patient ID is set in the expected output. That's what we expect to see, but we don't set it in our DTL at this point. And that's exactly what's happening here, right? The patient ID is not being set. It's disabled at this point. So let's enable it, compile the DTL, and run the batch again. And if you refresh the visual comparison, now we can see that the patient ID is correctly set. What we also can see is that the OBX segments are all screwed up at this point. So if you scroll down a bit here, we can see that we are appropriately looping over all the repeating groups, but that the OBX fields are not set. They're all disabled. We do have very high confidence that the target value comes from the source, but in very low occasions, we are not sure where the source value actually comes from. So let's enable those, as we have a high confidence that that's what we want to do. Why don't we do that? There are 3 more to go, and then let's do another run, right? So compile the DTL now, run again, and take a look at the output now. The OBX segments are all there as expected, and there's only one occasion here where something is off, and that's where you really have to go into the semantics of your DTL and make if statements and introduce them more complicated logic to deal with these cases. But overall, this approach allows you to quickly get to a DTL stub and then iterate on that DTL and improve it. Okay, now let's take a look at the key takeaways. DTLs can be generated if you can provide sample inbound and outbound messages. This is an iterative process, so we allow you to take this generate DTL class and improve it, run the tests again, and then see your KPI going up and up, right? And you can do this over and over in an iterative process, and I think that's a good and productive way of getting to a good DTL in a quick way. As a secondary side note, we also saw a tool to compare HL7 messages, especially in batches, so that can be useful. And the first big topic that we covered was how you can validate HL7 productions. After you've upgraded your server, or you introduce changes to your production, or when you move from one environment to another, let's say dev to test. All of these tools together build the final building blocks of the HL7 productivity toolkit that we introduced last year. And the overall idea is to boost the productivity. Keep in mind that all of these tools right now are not released yet. They're still in development. But feel free to reach out to us and let us know if you're interested to take an early look at it. We are happy to share what we have and take your input. As next steps, if you haven't already, you might want to take a look at the session Health Share Health Connect, new and next, which gives you an idea of where the product is moving and what the roadmap looks like. Never forget the learning portal at learning.intersystems.com, which has plenty of courses which will elevate your knowledge to further levels. Come and connect with us. We're all here for you, and we're always happy to share our insights and learn from you how you use our products and what you would like to see. So please reach out to us. On this slide you can see Craig Lee, who's the product specialist for Health Connect, Patrick Jameson, who's the product manager for Iris for Health, and myself, Stefan Wittmann. I'm the product manager for interoperability. With this, I would like to thank you for your interest, and please stay safe and healthy. Thank you and bye-bye.